So the very first thing that we will see, of course, is when you create a main file in Kotlin, and you can actually write a main function just like this, and this will be a Kotlin main function that just runs. And if you write like println hello world, this much code actually, if you run main kt, it just this much code is actually running, which compared to your Java code, you generally have to create a main class, and inside that you have to create a function called public static void main, and that's the function that actually runs. So this is running, and it gives you hello world as a result. So this function that has run, what is the equivalent Java code for this is like, if you go to your tools and inside Kotlin, so there is a tool called show Kotlin bytecode, and this actually shows you the bytecode that is generated from this Kotlin file, which is running inside your Java runtime environment. Okay, so both Java and Kotlin and another language called Scala. So these languages, they all run on the JVM. So with these languages, what we can do is we can compile these languages into something called bytecode, which is how it looks like, as you can see on the right side of the screen right now. And it has, like, of course, the bytecode has certain keywords which are actually pretty similar to your source code, but then it also has certain keywords which are not similar to your source code. Okay, so this bytecode is what actually runs on your JVM. And from this bytecode, like if I take any bytecode, I can also do is I can decompile it, and I can see what the equivalent Java would have been, like what Java code would have been compiled and we could have gotten here. So actually Java being a very old language, there exists a lot of decompilers out in the world, which actually look at some bytecode and they can reverse engineer the Java code from which it was formed. So right now my code has been, this bytecode has been compiled from Kotlin, not from Java. But the decompiler can take any bytecode, whether it has come from Kotlin or from Java, and it can reverse it back into Java to show what was the corresponding Java that would have created the same bytecode. Okay, so if I click on decompile, then another file opens up, and it contains some stuff like this metadata, which you can ignore. That is some artifacts that's remaining up from the decompilation process. But basically the code that we see here is the same code that would generate the the same bytecode that this main.kt file produces. So this Kotlin code, you can consider it to be equivalent to this Java code here, this decompiled Java code. And as you can see, what happens is that whatever is the name of your file out here, so basically if your file is named main.kt, in that case a class of that file name gets created, public final class main kt, and actually a public static void main function gets added into it. Okay, and what really happens is that a variable called hello world is created, and then system.out.println var 0 is what happens. So basically it's pretty similar as creating a Java file named main kt, and inside that if you have a public static void main and you print this thing. So although like when you're running Kotlin code, it seems like making a class is not important, and you can directly write functions and you can straight away start calling them. But essentially when it's running on the JVM or when it is running on Android, if you make files which do not have a class inside them, when they're converted to the bytecode, they actually are enclosed inside a class, because the way the Java language is designed and the way the JVM and the JRE run, it is important for any piece of code to execute. It needs a class, and only we can call things only within a class. In Java, like the language is not designed like C++, where the main function can be called without the existence of a class. So in C++, for example, object-oriented programming is optional. You can write object-oriented programming, you can also not write object-oriented programming, but in Java, classes are important. You can't create a main function without classes. So that's what Kotlin compiles. The Kotlin compiler does it for you, so you don't see it at the syntax level. It does not feel so, but that's what's actually happening out here. Okay,